how to use comparisons to find and tell the story in the data. So the agenda today, I'm going to show you an example or a collection of examples actually, and then draw some key learning points from those examples. Then we will look at some more examples with those learning points in mind, and then we'll take a review of all of that, and then we will go into the questions and answers. So a lot of the time we have a fact, a piece of information, a data perhaps from a market research study or an insight study from our colleagues in marketing, and we need to do something with that fact. So here is a fact. The height of the Petronas Towers in Kuala Lumpur is 452 meters. But it's really hard to get any sense of whether that's a big number. It's just over one lap of a running track, but that doesn't really give you a clear picture. So I'm going to draw on an image created by Ali Zifan, and that shows you a range of other tall buildings, in particular Burj Khalifa in Abu Dhabi, where you can see these really high buildings. So we look at the Shanghai Tower in China, the One World Trade Center, and these tall buildings, and now we have a sense of how big it is. And this is what we do all the time. How tall is John? He's a bit taller than Peter and not quite as tall as Sally. How hot was it? Oh, it was hot, but it wasn't as hot as it was today. We do comparisons all of the time. They're very close cousins to analogies, and they're one of the ways that we communicate ideas to each other all the time. So they're a great tool for communicating, but they're also a great tool for finding things out. Now, you need to get the right context. So maybe I'm presenting in Japan, and I look at all of these buildings, and none of these buildings are in Japan, so I haven't quite got the context I want. So I can then add to this diagram by Ali Zifan the height of the Tokyo Skytree. And again, that makes it more relevant. If I was in London, I might add the Shard. If I was in France, I might add the Eiffel Tower, so that there was a local reference point, which really brought it home to people how big something was and so on. Now, this is one of my favorite charts for looking at how we do analysis and how we find the story. This is more like finding the story than telling the story, this particular chart. And it's from Eurostat. And it's looking at deaths that could have been avoided if people had exercised, if they had have drunk less alcohol, if they have stopped smoking, and if they'd followed other health advice. So that's what is meant by an avoidable death. And what we can see here are several things, two types of comparisons in particular. The first is a comparison between men and women. The women are in blue, the men are in yellow, and we can immediately see as we look across the page that in every single country, men have more avoidable deaths than women. That comparison gives us quite a lot of information straight away, and we can see that in some countries, the gap between men and women is really large. And the second comparison comes by sorting. And one of the most important things you can do when you're analyzing data is sort it by the right criteria. So this table is sorted by avoidable deaths. The highest number of avoidable deaths are on the left. The lowest number are on the right of the countries in the EU. And then there are one or two countries that are not in the European Union, which are placed just to the right of the sorted set so that we don't obscure the data. And what we immediately see is that there is a group of countries that I've highlighted with a red marker, which are much worse than everybody else. And then when we look at those countries, we see that they are Poland, Czech Republic, Croatia, Estonia, Slovakia, Hungary, Bulgaria, Lithuania, Romania, Latvia. All of them from the old Eastern Europe, the old Soviet bloc countries. And what we can see is there is a really marked difference. So now we can see what the story is. If we're thinking about where should we be doing health interventions that is going to make the biggest difference, it would be in those Eastern countries, and it would be targeting men particularly. And we've done that without even knowing what the numbers are. We just know that things are much worse there than they are anywhere else, so that's where we would go. If we look at the right-hand side, we can see that the country that stands out is Serbia, another country very much like the one in the left-hand block from the old Eastern Europe. So we can see a very, very consistent pattern going on there. So let's think about how we start looking for data with comparisons with data. So this is some data from the ITU, which is the International Telecoms Union. They look after all the information internationally for the United Nations. And I've taken a bunch of countries here from the Asia Pacific area, and it's really hard to see any message. The decimal places hide it, the way the data is laid out hides it. It's sorted, but it's sorted alphabetically, which is often the least useful way of sorting information. So let's tidy that data up. Let's remove the decimal places and let's sort it from highest to lowest. So now we see that I've sorted it by 2017. And when you're doing that analysis with the data and you're looking for comparisons, you will probably sort it by 2010 and you'd sort it by 2017. You may sort it by the average over that period of time. There are different ways you can do that sorting when you're looking for the information. And we can see when we sort the data by 2017 that for every 100 people in Hong Kong, China, in 2017, there were 249 phones. That's about 2.5 phones per person because people have multiple phones. It does include tablets if they have the phone ability within them and if they've got a SIM in them and a subscription. And the table goes all the way down to the bottom row. And the bottom row we can see is more interesting. Myanmar used to have very, very few phones in 2010, 1 per 100 people. And now it's 90 per 100. Now that's not 90% of people having a phone because it's some people having 2 phones and 3 phones. But we can see there has been quite a dramatic difference. And that comparison of doing the sorting and looking at the biggest versus the smallest reveals that information. There are other ways we can do that sorting and comparison. So one other way is we could index the data on 2010. So whatever the number was, so the 1 in Myanmar becomes 100, the 57 in Cambodia becomes 100, and then we fill in all the other data. And again, we sort it by 2017, biggest number at the top, smallest down. So where has the change been greatest over those years? And by a long, long way, the biggest change is Myanmar, which is 7,586. Remember, it went up from 1 to 90. Massive, massive change. Down at the bottom end of our table, we can see that in Malaysia, Australia, Singapore, and Vietnam, there has been relatively little change between 2010 and 2017. Those countries all had more than 100 phones per 100 people in 2010, but they've not changed particularly over that period of time. So we can see some other patterns in that information. One of the things that we do a lot when we're trying to understand a complex set of data is compare it with a fixed case. Now, the fixed case could be the mean, it could be the median, it could be the total, it could be a country, it could be a region. So we think about which fixed case makes sense. So on this particular example on the page, I've shown the mean, which is on the bottom row and it's in blue. And we've got the data ranked from highest to lowest in 2017. And then I've used some colors to help those comparisons. So the greens are the countries where there are more phones in 2017 than is the case with the mean. And the brown are those where there is less than the mean. And the first thing that immediately strikes our eye is there are many more countries below the mean than there are above the mean. And that's because the ones that are above the mean, in particular Hong Kong, Thailand, and Indonesia, are a long way above the mean. So when we look at this, we might say to ourselves, do you know what? We should probably compare it with the median. That might be a better comparison. So this comparison process during the analysis of the data is very iterative. You look at one comparison and then you look at another comparison. When we're trying to show that information, we will often use charts. And one of the things that we need to accept is that charts show less data, but they show it with more clarity. So sometimes charts are helpful for finding the story, but they're particularly helpful when we're telling the story. And in this case, one of the things that we found from looking at the data is that Japan is very close to the mean. Now, we could say that in words, but if we show it as a chart with just Japan and the mean, it's immediately apparent to everybody just how close together Japan was the mean for 2010 and 11 and 12 and 13 and 14 and 15 and 16 and 17. If we had multiple countries on there, it would be less clear. We would have more data, but it would be less clear. By the time we get to telling a story, we want clarity in our comparisons. Another way that we can work out what's going on, because I kept sorting things, remember, by what was the picture in 2017. I could have maybe sorted the data by what was happening in 2010, but we can do other things that take all the data. So if we take, as I've done on this page here, Hong Kong and Japan, I can work out how far apart they are from each other across the whole period of time. Now, I could use correlations, but actually with this data, that wasn't particularly friendly. So what I've done is I've calculated the distance between the data from Hong Kong and the data from Japan. And that says the distance is 319. So I do that for all of the countries, and then I sort the data so that we have our comparison. And now what we can see is that Japan is 0 distance away from Japan. That's always reassuring when we've done the mathematics, that actually we find that we do have something as 0 distance away from itself. And quite close to Japan are Korea and New Zealand and Philippines. And down at the bottom end of the table, we have Singapore, Myanmar, and Hong Kong. And that data is okay, but there's not a lot of data there. So actually, we can make that comparison much clearer by showing it graphically. And when we show it graphically, what we see is there are only 2 countries that are very different to Japan over that period of time, from 2010, from 2017. It's Hong Kong, it's Myanmar. They are very different. That is the story. Now, once we've got the story, we might show it like this, but actually that leaves a question as to what is driving that difference. We can see that 2 countries are very different from Japan, but what might be driving that? So we can come back, and instead of putting lots of countries on the chart, we show Japan in blue. And then we say, look at Hong Kong, a country that's very different. And it's very different because it started well above Japan and it kept increasing. So the gap remained large over a period of time. The next country that is very different to Japan is Myanmar. And it is different because it used to be very different to Japan, and it's become quite similar. So there it had a very low set of numbers and it came up. And then we only include Singapore to say, and the third most different country really isn't that different. If you look at the green line and the blue line, we can see that actually there are only 2 countries that are fundamentally different, and they're fundamentally different in quite different ways. One is way higher and has stayed higher, and one used to be really low and is catching up with Japan. So we start to build a story where we've used comparisons to find that information, and then we can use comparisons to help us tell that story. So let's think about the key points in using comparisons in that way. Most values, most numbers are meaningless on their own. You scored a 7 on satisfaction. Well, you need to know whether that's a good score or a bad score. I have finished sometimes 10th in races, and actually it wasn't that good because there were only 11 people in my age category. I have finished 1,000 in races, and actually that was quite good because there were 14,000 people in the race. So we need what is the context for the number so that we can get some comprehension around that number. We've got to choose comparisons that create light. So it's no use talking about other things that people don't understand. You want to ground it in things that they already know. We want to create comparisons from the data, subgroups. So all those times that you do crosstabs and you're looking at male versus female, what you're looking for really are comparisons. We're looking for similarities and differences. Then we're going to do sorting. And sorting is probably the most fundamental tool in identifying differences and similarities. But you need to sort by the right thing. And quite often that will mean making additional variables so that you are sorting by the topic of investigation. And then once you've found the story, we can use comparisons to help tell the story. So Japan is similar to the mean. Hong Kong and Myanmar are very different to Japan. We can show those graphically really easily in ways that are 100% accurate to the data and are immediately obvious and are meaningful. Now, I showed fairly rough and ready versions of that. We, of course, could then, if we knew they were the presentation, use really nice infographics tools to tell the same thing more attractively, more impactfully, more engagingly. So let's take those points and think about how we're going to use them. NewMR did a study recently looking at artificial intelligence. We had 305 responses, and one of the things that we found was that 66% of the people we spoke to said that chatbots in market research are an example of artificial intelligence. So that raised the question, is that a high number or is that a low number? So let's see what we found from the data. In the market research tools, we said, which of these are examples of artificial intelligence? Chatbots, automated facial coding, and so on. We sorted all of these, and you'll notice that we didn't sort none of the above. So when you sort data, you should always think about which things should not be sorted into the list. So none of the above is a really typical example of something that you do not want to include. Other is often one that you do not want to include in the rankings because it loses its information, and actually it's a slightly different sort of information. And when we do that sorting, we can see that chatbots is the biggest number. Of the market research approaches we looked at, chatbots was the highest. So in the context of market research tools, 66% is a big number. We also looked at a whole range of things from everyday life and said to people, are these examples of artificial intelligence? The top two were Siri and Alexa. Then there was quite a drop down to the sort of facial recognition systems used when you go into and out of a country these days. And chatbots comes in there just behind Siri and Alexa. So now we have confidence in saying, yes, chatbots are comparable to Siri and Alexa. 66% is a high number. And also when we look at the data, we start to notice some other comparisons, and we notice that none of these actually is quite high. People who say that none of these are examples of artificial intelligence. So that will be our next line to go into to find out if we can use comparisons or other techniques to explain that. I want to show you an example from the SMR prices study, which I delivered at the SMR Berlin conference. It's a great resource, a great global study. And this is one of the charts which we used to tell the story. We had done some other comparisons to find the story, but here was the story we wanted to tell. We looked at the example of a simple usage and attitude study, 500 sample size, the data is collected online, there was no analysis or presentation, it was simply sent to the client as here is the basic information, we've grouped it, we've tabled it, but that's it. And what we have discovered, because this particular study has been tracked now since 2010, is that prices are falling. So if we look at the purple line, that's the online global median price, it has been falling. But if we look at the key markets, which is just USA, UK, Japan, Germany, and France, we can see that prices have fallen much further, and there is now almost no difference between buying this commoditized piece of research from an expensive country or buying it from a less expensive country. That is quite a radical difference. So prices are falling and the differences are disappearing. And we tell that with some really straightforward comparisons. First comparison is time. The second comparison is the key markets versus the global markets. We can use images to make comparisons. We do that all the time. And as you look around for the next 24 hours, just think about how many times in marketing, advertising, everyday life, people do those comparisons. So the before and after is a really, really standard way. In fact, it's so standard that I saw one when I was looking for the materials for this presentation, where the before was on the right and the after was on the left, and it just looked wrong. So we need to think about, when we use comparisons, what are the conventions? How do things mean? This is a nice way of showing a comparison. So it shows that the red is worth more than the greens. One of the changes, for example, we're seeing in the market research industry is we're employing more data scientists, which means in the future we may be losing interviewers and gaining data scientists, but there'll be fewer data scientists and they cost a lot more, or they earn a lot more, depending on which side you are of that process. So this sort of comparison immediately tells you that red is fundamentally different to green in some criteria. In Western societies, we have the porridge story, the framing. So you may want to use those comparisons, that this one was too big and this one was too small, but this one was just right. All of that works in terms of telling stories and communicating. If you want to know how small a tree frog is, then show it against somebody's hand. That starts to make things as a meaningful thing. But if you remember, in the first part of this session, I said to use comparisons that make sense. And there are some types of comparisons that the media keep using, and if we're not careful, we could use, which do not help. So swimming pools are normally a bad comparator. So what do I mean by that? Okay, well, last year in September, CNN was talking about Hurricane Florence, and evidently the meteorologists said it was potentially going to dump 10 trillion gallons of rain on North Carolina. Now, trillion is 1,000 billion, 1,000 million million. A million millions is 1,000 billion, and a billion is 1,000 million. So an enormously big number. Most people cannot even conceive of what it might be. So they wanted to simplify it. So they said, so how much rain is 10 trillion gallons? Well, we crunched the numbers and we figured out it was enough to fill 15 million Olympic-sized swimming pools. Two problems. Most people have no idea how much water is in an Olympic-sized swimming pool, and they have no idea what 15 million of anything looks like. So we're multiplying something we don't really understand by 15 million, a number we don't really understand. And then we get almost insanity just below that, or it's enough water for you to take about 581.4 billion showers. The 0.4 really does tell us that nobody has thought about this number, because the 10 trillion at the top of the page is probably somewhere between 9 and 11 trillion. So massive, massive wobble factor. So having a 0.4 in the bottom number really doesn't make any sense. But I don't know how much water a shower generates, and I have no concept of what 580 billion showers is as a measurement of water. So as a method of talking about water, this really doesn't work. By contrast, if they had said this was enough to cover the state in X centimeters or X inches of water, or this was enough to cover some area that people knew, or this was enough to cover a football pitch or whatever to 1 meter deep, 2 meters deep, those sorts of measurements are much easier to understand. But there are exceptions when the swimming pool works, and this is one of them. This is an article from Forbes, and it crops up from time to time. How many Olympic-sized swimming pools can we fill with gold? If you take all the gold that has ever been mined in the world, it would fit in 3 to 4 Olympic-sized swimming pools. Now, this time, that is a useful comparison, not because it's an accurate measurement. We still don't know what the volume of a swimming pool is. And anyway, maybe it's 3. Some reports say 2. What it is like a real shock, because most people, if they're asked to guess, would say, 100 or 1,000. But in fact, the absolute amount of gold that's ever been mined is really quite small. And that helps understand why we've been able to use it as a store of value over time, because there's a limited amount of it and it doesn't rot and it's still useful and it can be melted down and reused. And there's not much of it, we can use it as a store of value. So that is when a comparison is useful, because it has shock value. So we either want to talk about things that everybody knows. So if you did it every day, it would take you 25 years. Or if we piled these all the way up, they would reach from London to Manchester. Would be okay with British people, but it wouldn't be okay in another place. We'd need to localize that. But try not to say this complicated thing would be worth millions of that complicated thing, because that doesn't bring any clarity. We're using comparisons to create clarity, so we have to be using things that people understand. So let's bring all that together. Most values are meaningless on their own. Don't report satisfaction was this level. Particularly if you've got something like a Likert 1 to 5 scale, it is utterly meaningless. The number of likes that you've collected from social media are, without a context, quite meaningless. If on the other hand you say that's twice as many as last year, or it's half as many as our competitor, that starts to make sense. Choose comparisons that create light. So something that people already understand is going to be the best comparator. Create comparisons from the data. So don't just look at the data. Think, well, if I calculate the mean, or if I calculate the distance, or if I calculate how many standard deviations out it is, that may be the thing that you want to use for your input into your comparisons and your sorting. And then use comparisons to help tell the story. So use a subset of the data and make comparisons where there is a really clear difference. Don't show all the things where there isn't an interesting story, because that obscures the ones where there is. Show the cases where there are clear differences, where you can make a comparison, and that will help you communicate the message in a way that people can see, they can intuit, they can understand, and they can remember. So with that, thank you very much indeed, and I look forward to any questions you might have.
Hi Ray, thank you very much. That was a very interesting presentation, and a couple of quotes there that I'm going to have to cite you on in the future. I particularly like your quote about using comparisons to help create light. That's really nice. And what you said earlier about comparisons being a cousin of analogy really makes sense, because yeah, like you said, we do use comparisons in our day-to-day to explain even the most basic information. So really like that. Now I've got a couple of questions, Ray, while we're waiting for people to get typing their questions in the Q&A on the Zoom tool here. And my first question, it comes back to another interesting thing you said. You mentioned one of the things that is important to just get over about charts is that, yes, they will show less data, but show that data in a more meaningful way. And when I co-facilitate an infographics workshop, I often find that many of the delegates find it very hard to let go of the abundance of data that they have, because part of the process of making infographics is, of course, to to strip down almost and find the meaning of the data, and that crosses over with a lot with what you're talking about, Ray. So what would you recommend to anybody who's maybe been dealing with quite a big data set for quite some time? They're perhaps overly familiar, they're not really sure what to let go of, what to keep, but there's just that fear there of letting go. Do you have any advice for people who find themselves in that situation?
Yeah, you really have to show your stuff to other people to see whether they can make sense of it. Is it intuitive to them? Can they understand it? I know that you have spoken about this, possibly blogged about this before, but one of the best examples is the London Underground map. It's incredibly easy to read. I find it much easier to read than, say, the Paris Underground map. But it's geographically rubbish because that's the information they gave up. The person, you may remember his name, I can't, who designed it said, people, when you're traveling on train, don't actually need to know exactly where the stations are. They need to know how I travel between stations on these fixed lines.
Yeah.
So the map only has right angles and 45 degrees and 33 degrees, I think, as angles. Everything is set out really clearly. And so that was what they gave up there. If you think about the map with the Mercator projection, it comes from a globe, and they had to say, what can we give up so that it fits on the paper, so that still, if you take a reading from the map and then you fly or sail, it'll be accurate. And what they gave up was the size. They had to make everything towards the poles much bigger. So you will always have to give something up. I mean, maybe it's, when people are first learning, it's a good question to ask them and say, now, what did you decide to give up? Because they will often feel uncomfortable. Well, I didn't give anything up. I'm just showing everything that is interesting. No. You've had to give something up. If you've produced a nice graphic that's meaningful and tells a story, and people should really own that process, as opposed to thinking just about, I have shown everything that is interesting. They should be quite aware of what they have not shown and why.
And taking that step requires a lot of confidence, doesn't it? Because you are making quite a key decision to let go of some findings in favour for others that helped explain the story much more effectively. And so I guess part of that is just building your own confidence and just being sure about the steps you're taking.
Absolutely.
So we have a question here from an audience member who says, hi Ray, thank you. When using indices and comparisons where data is transformed, how do you explain the mathematical manipulations you made, especially when the audience is not savvy in math, without spending 30 minutes explaining your calculations in a 45-minute presentation?
Two steps. One is easily justified, and the other is justified by habit. So the easily justified, I will often do those processes when I'm finding the story, but when I'm looking to tell the story, I may not use indexes. I may show the data in another way. So I find it's a really efficient way of finding the information. The other way, frankly, is to be simply quite bold and say, right, now we've indexed the data, and what this shows is this, and do not explain it. There will be two groups of people in the room. Those who already understand indices, no problem. Those who don't, this is not the right time to train them in it. This is one of the classic cases there is where we would use a log scale. So if you have something that grows exponentially, so it's accelerating really fast, and you get that curve that points straight up, it goes along and then it shoots up towards the top of the paper. And you want to know whether that is related to something else, like the growth in income or change in health or something like this. If you take the log of that scale and it comes out as a straight line relationship, that's what you've shown. So you will put on the bottom of the chart log scale, but you won't explain it because half the room will know what a log scale is. They're happy. The other half won't. This is not the time to tell them. And that comes back actually to the point that Bedley was just making about you can't tell people everything in the presentation. So one of the things you are throwing away is the information about what an index scale exactly is and why we would use it.
Hmm. And I mean, to add to that, Ray, and this is a query I get a lot in my infographics workshop, is that sometimes there is a perception that if you're creating maybe a more simplified but arguably more effective approach to articulating data results and insights, that would replace any traditional, maybe much more lengthy and detailed reporting services. But I think what you're saying, Ray, is that this approach is complementary to that. But actually, if there are people that maybe not so savvy math, there are some other things that they need to know that can all go in a companion detailed report that might follow a face-to-face presentation or some slides that you're sharing with a client over webinar or similar.
Absolutely. And if we talk about, today, for the purposes of this investigation, I showed on the page how I calculated the distance between two lines. I would never dream of doing that in a presentation, just as I would not explain how I calculated correlation.
Yes.
People in the room either know what correlation is or they don't. And a presentation about the impact of expenditure on the advertising results is not the place where you teach somebody about stats and numbers.
Yeah.
And if you've got an audience that is unhappy with you using numbers you've not explained and they don't know about these numbers, then you have to tell the story in a quite different way. So you've used those numbers to help you find the story, but then you go back and say, now what can I do graphically?
Yeah.
What can I do by actually showing those numbers in another way that will tell the story that I've used these techniques to find? And this is perhaps the most important thing for anybody who is savvy with numbers. How you find the story is unconnected with how you tell the story. How you tell the story is all about the audience, and how you found the story is all about the data.
Mm-hmm. And yeah, that goes back to what you were saying earlier, Ray, about finding some ideas and comparisons that are rooted in what you know your audience will know. So that requires some maybe extra research on your part as the person who's articulating those insights to know about who's going to be in the room. It's reading the room, isn't it?
Absolutely. So I run with people in different parts of the world, and when we talk comparisons there, if I'm in the UK, I will talk minutes per mile. From the United States, I will talk minutes per mile. Everywhere else, I will talk in the real units, kilometers.
Yeah.
And if you want to talk about something being hot in the United States, you will talk in Fahrenheit. And if you want to talk about something being hot in France, you will talk in centigrade.
Yeah.
You have to put all of your reference terms, all of your analogies as being what is known in that country. So it's not just the Eiffel Tower or the Shard or the Empire State Building. It is really understanding what this audience knows.
Yeah.
If we're talking to pharmaceutical clients, you're more likely to draw on comparisons with previous events in pharma. But if you're talking to auto clients, you'll be talking about comparisons that are drawn from auto.
Yes, yes.
Yes, this is something which happens particularly if you have somebody who does advanced analytics, who is a real hot shot at conjoint analysis, perhaps using hierarchical Bayes to do their modeling, is that when they get to the presentation, they want to talk about what they did to find the story. We did this analysis, we did this, we used these assumptions. And clients are generally, A, not interested, and B, often not competent to understand that description and that method. When you tell the story, it's nothing to do with how you found the story. How you tell the story is based on what the audience already knows, what is readily available in the data, and the message you want to convey. And you start there. You don't start with, I did this analysis and I did this analysis.
Yeah.
And it is quite strange for statisticians to look at the information that way and really to ignore the process they went through to find the story, because how you find the story is not the story.
Yes, yes. Yeah, that's such a good point. And actually, I'm just thinking about lots of other things that where people wouldn't spend time explaining how they got to the end result, because that's not really, there's a time and place for that sort of thing, isn't there? Ray, while we're waiting for a few more people to maybe ask some more questions, I've got one last one for you, and that is that comparisons are one of the things that help to provide context, because that's really what we're talking about here, giving context to the information that we're sharing with our clients or whoever it might be. Apart from comparisons, can you think of any other things that might work quite effectively to give some context when you're articulating research results?
One of the key ones is close to comparison. It's similarities. So you'll be talking about how we build on previous research. So putting it into buckets. This is in the top 25%. This is in the bottom 50%. This is in the top quartile, deciles, all of those sort of things. They are sort of using comparisons already, but they're one of the standard ways that we frame things. Yeah. Then there are times when you will use absolute language. So, this is an excellent result. There's an implied comparison in that, and that not everything can be excellent, even in this sort of modern world where taking part is sometimes rated as highly as winning. But absolute phrases, nobody liked this, everybody loved this, this is a great idea, this caused a lot of excitement. So there are times when we will use absolutist language because that works and you don't need the comparisons then. Because it stands on its own.
That's a really great point, Ray. And there is always going to be a need for that kind of language, isn't there? When you just want to get straight to the point in the story. And so, Ray, that's the end of the questions. I don't have any more on the panel. But one thing I will say about comparisons, which is very important, and I don't know if you or any of the listeners might have seen it, that people buying very expensive Persian rugs on eBay, because the photographs weren't showing the scale or comparing the size with something else, they were receiving very, very tiny little bits of fabric in them and paying top dollar for them. So that's another importance of comparisons there.
It is, and comparisons are also a source of error. So you can, if you don't know very much about wine or something like this, assume that the expensive ones are going to be better than the other ones, because we will often substitute a comparison for something we understand, and this is then moving very much into behavioral economics, for something that we do understand. So we understand money, therefore we think the more expensive one is going to be better than the less good one. Because that's the way around that works. So thank you so much, Betty. Thank you very much to the audience.
And thank you, Ray.